In this video, I'll be looking at the graph of quadratic functions. That is, graphing quadratic functions. Typically, the graphs are called parabolas. And the graphs have a U shape. The graph either opens up like so, or they open down, something like this. They're fairly easy to graph if you just want to sketch, because if the graph opens upward, the lowest point on the graph, referred to as the vertex, is all you need to really just sketch it. If it opens down, the highest point on the graph is the vertex, so you would simply plot the vertex and either draw the graph opening upward or downward. So they're fairly easy. Lines, almost as easy as lines. With lines, you need 2 points to determine a line. So let's look at the different forms that you can have. These standard forms here. So let's look at the first one. Quadratic function or parabola has the form f of x, or y equal f of x is equal to ax squared plus bx plus c. Now the condition here is that a cannot be 0. Okay, if a is 0, then basically you don't have the square term, you just have bx plus c. So that represents a horizontal line, or a slanted line. If b is equal to 0, then you've got a horizontal line passing to the point 0, c. If b is not equal to 0, then you have a slanted line. Okay. So they're easy to graph. The parabola itself, like I said, really all you need is 1 point. If you just look at wanted to find a rough sketch of the graph, the vertex is all you need. So if it has the form ax squared plus bx plus c, where a is not 0, then the vertex is given by minus b over 2a. Okay, that's the first component of the vertex, and the second component of the vertex, or the y value if you want, is f of minus b over 2a. So in other words, if you find the first value of the point, then you just plug it into the function. Okay, and it's going to open up if the a is positive, and open down if the a is negative. Sometimes you'll see the form y equal f of x equal to a, and then parentheses x minus h quantity squared plus k. In this case, the vertex is given by hk. And again, the graph opens up if a is positive, and opens down if a is negative. Now, the most basic parabola you can have is one that has the form, say, y equal x squared. And this one has both these standard forms if you use your imagination here. So if I look at the first form, ax squared plus bx plus c, there's no number in front of the x squared, so that's understood to be 1. So a is equal to 1. There's no x term, so b is 0. There's no c term, so c is 0. So if I use this formula here, minus b over 2a, then that would be minus 0. The b would be 0 over 2 times a. A is 1. So this would give me 0 divided by 2, which is 0. So the first component of the vertex here is 0. And then if I plug in 0 over the x's, I get 0. So this is a parabola that has vertex at 0, 0, and opens up. Okay, so it's very easy to graph. I also want to point out that the a value will determine how wide or how narrow the parabola is. Obviously, you can select other points if you want to determine how wide or narrow it is. But just to give you an idea, let me look at the graph on the calculator just to make it easier to C. Okay, so here I have three functions entered. The one I'm going to look at is the first one, y equal to x squared. So if I hit graph, okay, that's what the graph of y equal x squared looks like. Vertex at 0, 0. A is 1, that's positive, so it opens up. Now the a value is going to determine, like I said, how wide or how narrow the graph is in relation to y equal x squared. So if the a value is greater than 1 in absolute value, so in other words, say it's 2 or negative 2, 3 or negative 3, greater than 1 in absolute value, then the graph is going to be more narrow than this. So let's look at an example. So in the second one I have y equal to 2x squared. So that could be a negative 2. So keep in mind that if the coefficient there is negative, the graph just opens down. But let's go ahead and select this one. So now you're going to see both graphs. So let me select this one also. And now let's look at the graphs. Now it's going to graph both of them. Okay, so there's the y equal x squared, and then you can see that the y equal 2x squared falls inside that one. So it's more narrow. Now let's go back. And let's look at all three now. Okay, so now we're going to look at y equal 0.5 x squared, or 1. No, the coefficient a is 1/2. Okay, so it's smaller than 1 in absolute value. Okay, smaller than 1 in absolute value. So if I look at the graph now, okay, so there's the one on the outside, this one right here, that is the graph of y equal 0.5 x squared. So you can see it's wider than the y equal x squared. Okay, so that gives you an idea as to what to expect in terms of the value of a. Okay, now let's clear this. Okay, so this says if the graph has the form ax squared plus bx plus c. And before I go to the next one, let me just point out on this one I meant to look at it, put it in both forms. I looked at the first form, but it's also in form 2, because I can write the x squared, I can write it as 1 x minus 0 quantity squared plus 0. Okay, and I looked at the other form where it was y equal to just x squared, and I said this is understood to be 1. There's no x, so this would be 0 x. There's no c, so that would be 0 also. And it's a little bit messy here, but anyway, the x squared can be written as y equal x squared can be written as 1 parentheses x minus 0 quantity squared plus 0, or 1x squared plus 0x plus 0. So in the second one, the a is 1, like I mentioned earlier, the b is 0, the c is 0, and of course you can find the vertex by plugging into this one. But if I write it in this form, then the h here is 0, and the k is 0, so the vertex again is 0, 0, and then of course it opens up because the a is positive. Okay, just wanted to make that point. Okay, so let's look at the graph then of this one. Y equal to minus x squared. Again, here I'm using the y. You could use f of x if you wanted in functional notation. So using the formula above, it's the first component of the vertex is minus. Oops, that one black here. the first component of the vertex is minus b. Okay, so in my case, b is 8, so that would be minus 8 divided by 2 times a. A is negative 1. So that would be negative 8 divided by negative 2 is positive 4. So the vertex, first component of the vertex, is 4. Okay. And then the second component is basically found by replacing the x by 4. So put a 4 where the x is. So put a 4 there. That would be 4 squared is 16, and the minus makes it minus 16. 4 times 8, that's 32. Minus 9. Okay, so minus 16 plus 32, that's 16, and then minus 9 gives me 7. So the first component, or the second component of the vertex is 4, 7. And the a is negative 1. So since it's negative, the graph then is going to pass, we'll have a vertex at 4, 7, and then open down. So as a rough sketch, so now we just go over 4 units. On this side, and 7 units up. So from 4 and then to 7 right here, that would be your vertex, and it opens down. So from here then the graph is going to come down like this, and it just keeps going down, U-shaped at that point. Okay, vertex at 4, 7. Okay, so let's clear this. Okay, so notice this has the second form. So look at the second form over here. That's x minus h quantity squared. The vertex is hk. So in this case, the vertex is going to be x minus 2. So that'd be h would be 2 plus 3. So k would be 3. Okay, had this been a plus 2, then to put it in the standard form, you'd have to write it as x minus a negative 2, so this then would be negative 2. Okay, but in this case, it's 2, 3, so I go 2 over, and 3 up. A is 2, which is positive, so the graph opens up. So from that point it goes up like that. Okay, so that's what you need to do to find to sketch the graph. Just find the vertex, determine which way the graph opens, and you've got a good sketch. Now you could also plug in some other values if you wanted to be more accurate. You could plug in numbers larger than 2 here, numbers less than 2, and get a couple of more points. Okay, but if you just want a sketch of the graph, the vertex, and then deciding which way it opens, you've got your sketch. Okay, now I've got a bunch of videos on this channel. I also got another channel where I have videos on algebra, calculus, trigonometry, and so forth. So check those out, and if you have any suggestions, as always, please post them. Or if you want more details in some of the videos, just let me know. And please subscribe, and we'll see you in the next channel for the next video.